Hello everyone and welcome to the vets.to.coders. This is the part 2, the object-oriented programming, and today we're going to be covering stacks, heaps, and some dynamic arrays. So for stacks and heaps, the stack is a memory location that is stored locally and the garbage collection is taken care of, and we'll get to what that means. The heap allows for the memory to be stored globally, which means that the user must delete the memory. So here we have the stack on the left, creating 4 integers, 2 variables, and 2 pointers. So the 2 variables are static and they stay on the stack, and then the 2 pointers are pointing to 2 variables that sit on the heap. Now the only way to access any variables on the heap is through a pointer that exists in the stack. So a stack pointer has to point to a variable on the heap. That's the only way that we can access variables. You can't access variables directly on the heap like you can on the stack. The stack is how we've been storing variables all along, so anytime that we've created a variable, it's always been allocated on the stack. The stack memory has to be known at runtime, and we'll get to what that means when we do some coding portion of it. The stack memory cannot be significant, such as we can't create an integer array that is greater than 3 million, and garbage collection is taken care of. For the heap, the location to store the variables can only be accessed through a pointer on the stack, and that's what we covered already. That we have an int pointer, and that pointer points to a variable that sits on the heap. The heap memory is dynamic, and the size can be made at runtime. The heap memory can be very large. I tried to depict it with the pictures. You want to think as a stack memory as a rather small memory, and the heap memory is very large. So this is how it would look in code. So we have an int pointer creating a pointer, and that pointer points to a new int. So this is the first time we're seeing the keyword new. What that means is the keyword new means allocate something on the heap, so a dynamic allocation. So it's creating a new integer, and we're creating that new integer on the heap here. Now we're telling that pointer to hold the value of 15. So the value of 15 gets assigned to the pointer. And then whatever you want to do to manipulate your code comes here, and then whenever you use keyword new, you have to follow it up with keyword delete. And the reason is once all this code is completed, the local destructor for the stack is going to come through and manually delete everything. So one of those things that's allocated on the stack is this int pointer. The integer here sits on the heap, but this pointer sits on the stack. So it's going to come through and it's going to delete everything on the stack when the program is executed. And it's going to delete this pointer, but leave this integer on the heap, which means this value stays, we lose this value, and because we lose this connection, we lose this value forever. That's what's called a memory loss. And the way you prevent memory losses is every time you create a new variable, you ensure that you delete it. Now, some dynamic arrays. We can now create some arrays where the memory is dynamic, which means we do not need to know the size at compile time. So what that would mean, I cannot create an array. I can't create an int array of the user input size. The way to do that is you have to use a pointer that points to a dynamically allocated array. The way you do that is int pointer, and the pointer, we're going to call it dynamic array, equals new, which means we're creating it on the heap, and it is an integer, and these brackets tell us that it's an array. So it's an integer array, and the size is size of array, which happens to be whatever the user inputs. So when we compile this code, this array is not known. We can't hard code the size because we don't know what the user's input is yet. So this code has to wait for user input on this line in order to tell us the size of the array for the next line. That can only be done dynamically. So ask user for input, receive the input, create the array dynamically, and then we just go through and just give it arbitrary values. Then we end with deleting it. Lastly, the brackets operator is also a dereference. So what we see right here, these brackets are also dereferencing. Normally you would have to dereference to put a variable into the dynamic array or a dynamically allocated variable, but because these brackets are here, that acts as the dereference. So if you guys are wondering why there's not a dereference, that would be the reason. And lastly, here's how you can get some help. Now we're going to bounce over to some code. Now let's do some code. We want to first include our libraries, so that's easy. Include some IO stream, and then we'll do our using namespace standard. Next, let's int main, and we'll put this here. Okay. So create a static array of 3 million. So this is to show that you can't create, first let's do return 0, but the reason why you're doing that is to show that you can't create variables of 3 million because that is too big for the stack. So int array, let's do 2 million. 1, 2, 3, 4, 5, 6. Oops, and then we'll close it. Save it, build it, run it. 2 million, okay, so an exit value of 0. So this executed fine, no issues. Went through, executed, returned the value of 0, so we had no issues with this code here. Now let's increase the int array to 3 million. Save, build, run. Terminated with an exit value of -1. So something happened here. There was an error in the runtime, so nothing. So if I were to put cout high, whoops, sorry, and then we'll run this, that high will not get executed because this 3 million is breaking the code. But if I were to change this to 2 million, it'll still execute. So this is an example of an error where it's not showing us an error because this is what's called a runtime error. It's not what's called a compile time error. Compile time errors are caught when it's compiled, such as if I were to make that mistake and compile it, that is a compile time error. It found it. A runtime error is an error that is found once the code is ran. Of course, now that it's 2 million, we see that it executes high. So that's an example of an array being too large. So my stack on my computer cannot handle an array of a size larger or as large as 3 million. So we just want to show that when it's 3 million, it crashes. When it's 2 million, it works fine. So I'm going to set it to 3 million, but I need to comment this out. So create a static variable. Okay, so int size of array, ask for user input. Okay. So cout, enter the size. Next, we'll go for the cin, and they're going to input the size of the array. Create a dynamic array. So let's do an int pointer, and we're going to do dim array equals. So now I need to create something new on the stack. It's going to be an int, and it's going to be an array. And the size of the array is going to be whatever the user inputs, which is size of array. Next, let's load the array. So we need a for loop here. Oh, I didn't close that. Next, I need a for loop. For int I equals 0. I is less than size of array. I plus plus. And so we need to load the array. All I'm going to do is I'm just going to do dim array index I, and I'm going to do what we had in the PowerPoint, which is just I times I. Just some arbitrary values, and then we're going to print the array. So let's copy the same for loop, and I did not close it. That's why it's giving me an error. Close that there. So we did a oh, that's because I put it in the wrong spot. Okay. Now before we did an assignment, now we're going to do a print. So just say cout dim array index I, and I just want to do a space in between. That's good. And you make sure we delete our pointer, of course. Yes. So delete dim array. So anytime we see the keyword new, we need to follow it up with the keyword delete. So let's run this. So we commented out our 3 million. So we have size of array, asking the user to input the size, taking in the size. Here we have our creation of our dynamically allocated array. And then we have our assignment, and then we have our assignment. I think that is indented one too many. Save, let's run this. So enter a size. So if we do 4 and we do enter, so the first input should be 0. So 0 times 0 equals 0. So 0 is going to go in index 0. 1 times 1 equals 1. So 1 is going to go into index 1. 2 times 2 is 4. 4 is going to go into index 2. 3 times 3 equals 9, and that is going to go into index 3, and that should be the end of it. So that should be everything that it prints. So 0 times 0, 1 times 1, 2 times 2, and 3 times 3. Awesome. So that is everything. I hope that makes sense on the difference between the stack, the heap, and a dynamically allocated array.